just, okay. So yesterday we talked about 0 exponents. And what did we say? Anything to the 0 power is, it is 1. Although, there is one thing that you do need to know. X to the 0 equals 1. The only thing raised to the 0 power that does not equal 1 is 0 to the 0 power. And this is what we call an indeterminate form. And you really don't have to worry about that too much because I'm not going to give it to you. But just so you know, for your greater knowledge, anything a 0 raised to a 0 power can't really be determined. This would also be true about things like 0 divided by 0. You can't do 0 divided by 0 because that means, if you think about, like, if I have 10 divided by 2, that means I got 10 cookies and I'm trying to split it in 2 groups. But if I have 0 divided by 0, I have 0 cookies in 0 groups, which doesn't make any sense, right? Like, that can't happen. So indeterminate form here, that's something I do a lot with in calculus actually, but that's just for your own personal information. So yesterday, when we were talking about x to the 0 power, I made like a chart, right? And we were saying, like, if I had 2 to the 3rd power, that was 8, right? 2 times 2 times 2. And if I had 2 to the 2nd power, that was 4. And 2 to the 1st power was 2. So 2 to the 0 power was 1. Right? What were we doing each time? Not taking away, but dividing by 2. So, just using that logic, this was 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. So if I've got, sorry, this is getting, I'm going to make my line move over here. Let's do this so that you guys can read it. Let's do this. If I have 2 to the negative, it's not done that before, 2 to the negative 1. My pattern, I would just divide by 2 again. Coach Wood, you got a question? No. I would not. I'd just be glad that they could do an inverse. Okay. All right. So if I divide by 2, I would have 1 divided by 2, which is 1/2. Right? If I had 2 to the negative 2, I'd divide by 2 again. Oh, what is that? That one's trickier. 1/2 divided by 2 is 1/4. All right. Do you see a pattern happening here? What do you think the next one would be? 1/8. And then you get 1/16 and 1/32 and so on. Okay. So what's happening with those negative exponents is it's becoming a fraction, right? This 1/4, I could write that as 1/2 squared, right? 2 squared is 4. And this I could write it as 1/2 to the 3rd. So I like to teach you guys a purely non-mathematical way to remember this, but maybe it will help you remember how to deal with these. Negative exponents are like bad children. Okay? Isabella, she had her music in yesterday, but she almost witnessed me dealing with my bad children yesterday. We were already almost late to the ball game, and Hunter couldn't find his jersey. Yes, we were looking in the van. Yeah. It was in his bag that he had already looked through 3 times. But he'd crammed it in like some pocket that didn't make sense. So, anyway. So, bad children. What do we do to negatives? Like a negative exponent's bad. We don't want to have to deal with it. So, what do we do with bad children? You could have lots of answers, but the best answer is you don't throw them away, but you're close. You throw them in the basement. Okay? Yes. So, if you have bad children, right, I'm glad you had your music in, because I was yelling at them. Because I had asked him like 5 times, Hunter, you got all your stuff, you ready to walk out the door? Yeah, Mom, I'm ready to go. We were going to, Henry was playing first, but Hunter also had a basketball game. We're going to the basketball game. And, like, as I'm getting in the car, it's like, Mom, where's my jersey? It's like, was that not one of the essential pieces you need to have to be ready to go? Everywhere. Loud enough. Thank goodness. Yeah. Thank goodness you had your music in, because I was not dealing with his incompetence very well. But we found it, and we made it to the game. And they won, and it's the first basketball game Hunter Hyatt has ever won, because last year's basketball team did not win a single game. In fact, last year's basketball team did not score double digits in any games that he played. None. It was pitiful. But this year's been a little better, but we had still not won any games, but they won last night, so he was so excited that they had won. So it was the better team. It's at the rec league. There's only 3 teams in his age group, but the last time we played this team, they beat us 30-12. So it was a pretty big victory. I mean, this was like, it was, yeah, and they got, this is also the first, like, they have gotten double digits a few times with this team he's playing on, but they still didn't win. But they scored over 20 points. It was like 24-23 or something. So, and it was a close game, and they beat us so bad last time. So, I mean, it was a victory that made us forget that we started the evening yelling. But anyway. All right, so bad children, you lock them in the basement. So this x to the negative n, we're going to send him to the basement, because right now he's in the top of the fraction, right? There's no fraction bar there, but he's in the top of the fraction. So we're going to lock our negative exponent in the basement, and this will improve his behavior, and his exponent will become positive. Why did it turn to an arrow? I don't know. Yeah, I have no idea. So, this will fix his behavior, and we have to put a 1 in the top because you have to have something in the top of the fraction. Well, his was the second game, so my husband was coming later, and I was going to make him stay with him and look for it. Well, if we couldn't find the jersey, though, I was just going to make him wear Henry's, because they look the same, but Henry's is just smaller, so he was just going to have a tight jersey. Yeah. All right, so, yeah, if he did, I would just lock him in the basement and take Henry to this game. Not really. I don't actually lock my children in the basement, so don't report me. This is just to help you remember what to do. Okay? So, yeah, right. Some houses, however, do not have basements. So you might be thinking, what could I do with these bad children if I don't have a basement? So if you don't have a basement, maybe you also have an attic. So here is a situation where the bad child is already on the bottom, right? So if you have a bad child that is already like on the first floor, on the bottom, there's nowhere to go down, you can send them to the attic here, and it will also improve their behavior. They will have positive. And then if you want to put a 1 here, you can, but you don't have to, because you don't have to keep that in the bottom of the fraction. So that'd be x to the n power. Yeah, I mean, I'm not actually advocating this as a way to deal with bad children. So before you go home and lock your little brother or sister in the basement and say that Miss Hyatt told you so, I'm telling the recording so there's evidence. No one should ever lock children in the basement unattended or the attic. Yeah. We won't go down all the avenues for this, but I'm not actually advocating this as a discipline policy. And I do not lock my children in the basement or the attic. I do not. I know. So just set the record straight. And she doesn't even watch the whole thing. She only watches the part where I tell you to lock children in the basement. Yeah. Then it ends up on the news with me telling you to lock children in the basement. Nobody's listening to the second part where I say don't do it. This is just to help you remember. Let's hope this doesn't happen. Okay. No. All right. This is really important for you to remember. Negative exponents do not mean negative numbers. In fact, in most cases, the value of the function becomes positive when you deal with those negative exponents. It's not going to be, speaking of bad children, do I lock you in the basement, Hunter? I did not do this. Wow. He knew he was setting me up. I do not lock him in the basement. He's lying. Huh? Yeah, if I'm not here in the morning. No. But, okay. So, no. Thursday and Friday I have smart breakfast. Tuesdays I have to. So, watch where the parentheses are when you're working with exponents. Everything inside the parentheses is raised to that exponent. If there are not parentheses, only the thing right in front of it is raised to that exponent. So, dealing with negative exponents is going to look like this. If we have 5 to the negative third power, right now there is no fraction, so everything's in the numerator, right? We could put this over 1. So we're going to move it to the bottom. We're going to make the exponent positive. Because you have to have something in the top of a fraction, we're going to put a 1 there. And then we can, because this is 5 to the third, we can actually figure out what that is. That's 5 times 5 times 5, which will give us 125. So 5 to the third, negative third power is 1 over 125. Notice it's not a negative number. It's a positive number. So negative exponents don't mean that you have negative numbers there. Who wants to try the second one? Yes. Yes. Perfect. Good. All right. Caitlin, number 3. Sounds like a good idea. Caitlin thinks this is a good idea. Yes. Yes. X will be to what power? With an N. Positive N. Because this fixes their behavior. They are no longer negative. They're positive now. So this is our negative exponent. Okay. Make sure she sees the part where I say you should not lock children in the basement. Yeah. She might be like, she might. Okay. Yeah, I have not told you you can lock anybody in the basement. All right. Okay, enough of that, though, so we can get through our notes. 5 to the 0 is going to be 1. Y to the 0 is going to be 1. X to the 0 is going to be 1. We already talked about that yesterday. All right. Okay, so let's look at what this looks like with problems that are a little bit more complicated than just these basic ones, okay? Actually, 7's still pretty basic. For this one, Giancarlo, what would we do for this one? Good. What's it going to do to its negative exponent? Is positive. What do we have to put in the top? 1. And then for this one, we can actually do 2 to the 3rd power. So what is 2 to the 3rd power? 8. So 1/8. Why is it disappearing whenever I write it? Y'all are seeing this, right? It's insanity. All right. Y'all, I might not should use this analogy anymore. Why is 8 going away every time? Maybe I need to draw my 8 like that. That worked. It doesn't like the double circle 8 for some reason. Even though I do it all the time in the same program. This is an old worksheet. It's in compatibility mode. Maybe that's throwing it off a little bit. Okay. All right. 8. Okay. Now this particular case, we got 3 to the negative 5. So, Evan, what are we going to do to deal with that? Good. All right. And what about the exponent? We make it positive. If we want, we can put a 1 in the bottom, but you don't have to do that. It's just 3 to the 5th. The one that's already up there, that's a good question. It's just multiplied by whatever you've moved up there. So 1 times that 3 to the 5th is just going to be 3 to the 5th. And 3 to the 5th is 3 times 3 times 3 times 3 times 3, 243. Okay, let's look at what to do whenever we start getting other variables and different things there. So when you have negative exponents, unless there's a set of parentheses showing you that the negative exponent goes with more than one thing, the negative exponent only goes with the variable or the number that is right in front of it. So that 2, and it drew a purple box around it, but now you can't hardly see it. There we go. Okay. That x to the negative 2, the x is the only thing that has a negative exponent. The 2 does not have a negative exponent. Okay. So it's only the thing right in front of it, unless you see parentheses grouping stuff together. So what you're going to do is everything else stays where it's at. The 2 stays where it's at. The y to the 4th stays where it's at. Because those children are behaving themselves. They don't need to move. They're fine. The x to the negative 2 needs to go to the bottom, and we need to change its exponent to make it positive. Now, probably you'll see this written as 2 over x squared y to the 4th. You don't have to switch the order of those. It's just more common to see them in alphabetical order for that. Okay, and you can't combine any of that because you have different variables. All right, for 10. Okay, what do you want to try? There, Isabella. You still have a negative exponent. I don't want any negative exponents in the answer. So this negative exponent right here, it's got to go up to the attic. So whenever we move that up to the attic, what is my answer going to be? 4 stays on the bottom. You can move coefficients, but to move coefficients, they'll either have to have their own negative exponent, or they'll have to, we'll see on number 12 right here, we're going to move the coefficient, but it's because we have parentheses that group it together. So if you have parentheses, like for example, if I had 2x to the negative 2, I would move the whole thing to the bottom and give it a positive exponent. But you have to have those parentheses for them both to go. Does that make sense, the difference there? Okay. So otherwise, the coefficients just stay where they're at. Okay. All right, so for 11, you got a couple ways you can deal with this. Okay. You can raise both of these to the second power first, if you would like. And that'll look like this. 3 squared is going to be 9. And then I'll have x to the negative 4. But we don't want to leave any negative exponents in our answer. So for this, because that x to the negative 4 has a negative exponent, it needs to go down to the bottom. All right, and that will be 9 over x to the 4th power. Could anybody think of a different way I could do that? A different first step? If I want to, I can deal with the negative exponent first. So right now, that x to negative 2 is in the top. I could move it to the bottom. So it would look like this, 3 over x squared. And then I could raise everything to the second power, which would give me 9 over x to the 4th. Both of those give you the same answer. It doesn't matter which way that you do them. Really, there's one's not necessarily easier than the other there. So as long as you are following the rules, you can do these either way. Okay? All right, for 12, again, there's a couple ways that you can do this problem. Okay? If we do it the first way that we did this problem, we would raise everything to the negative 3rd power. So that would, I'm going to write this as 5 to the negative 3rd because I don't really know 5 to the negative 3rd so well. It's going to be 1 over 125. And then we'll have x to the negative 6. And because those both have negatives, it's positive. Because what happens with this is this stuff right here is in the numerator. We're going to send it down to the bottom, and it makes the exponents positive whenever we do that. And we have this 1 in the top here. And so this is 5 times 5 times 5, which is going to be 1 over 125 x to the 6th. So negative exponents don't mean negative numbers. Most of the time, not always, but most of the time it's going to be a positive number unless you're starting with something different. Your other option on this, 1 over 5x squared to the positive 3 power. So I moved that stuff to the basement and made its exponent positive. And then I can raise both of these things to the 3rd power. So you're doing 5 to the 3rd, x to the 6th. You get the same answer over here. So you can do these in a little bit different order. It'll be fine. All right, questions? Okay. All right, so 13. What do you guys think? Okay. Aiden's saying a squared. He is correct. How'd you do it so quick? How'd you just add your exponents? The rules we've already learned still apply, right? So negative 5 plus 7 gives you 2. Or you can send that to the bottom. You'll get a to the 7th over a to the 5th, which will be, again, a to the 2nd whenever you subtract those exponents. So either way will get you the right answer there. Oh my, let's look at 14. What do you guys think? What do we have to do first? Okay. Let's let's raise everything to these powers right here. Okay, so I'm going to have 2 to the negative 2 power, a to the positive 2 power, times 2 to the 4th power, a to the negative 4 power. Okay, you got options here. Probably the quickest way to deal with this, just to I got 2 to the negative 2 and 2 to the 4th. So if I add those exponents, that's 2 squared. And then I've got a squared, a to the negative 4. So that's going to be a to the negative 2, which is 4a. I mean, it wasn't bad that it changed that first. You could. And so that'll go to the bottom there, and 4 over a squared. You could deal with your negative exponents inside the parentheses first and then raise everything to the power, but they're going to turn back negative and you're going to have to send them back up. So I usually just do the exponents first here. Okay, 15. We could raise everything to the 2nd power, and Isabella is correct. We know that all of these without exponents would have an exponent of 1. So that's going to be x to the negative 4 y. Doing this, x to the negative 4 y to the 2nd times x to, I know, x to the negative 2 y to the negative 2. I would go ahead and put this stuff together before I... which one? You are correct. Y is not going to exist anymore because we got a positive 2 and a negative 2, and those are going to cancel each other out. All right, when we add those together. So we got x to the negative 6 when we put that together, but we can't leave negative exponents in our answer for this worksheet, so we're going to have 1 over x to the 6th. All right, let's look at 16. Yes. It's not going to be 2 over 1 because that 6 is raised to the 2nd power. Oh. So I would go ahead and make that 36. Oh, gracious. And then here's what I would do. I would start moving stuff. So this a to the 2nd, yes, it is. It's going to go to the bottom there. So b, it is going to change into 12, yes. And if you wanted to go ahead and do that, that's fine. So the 36 stays where it's at. B to the 3rd stays where it's at. The a squared has got to go to the bottom. So I already have an a, and now I also have this a squared and the b to the 4th. So I'm going to put those a's together. And I'm going to also do like Linnaeus said, both of these are divisible by 3. So I'm going to make that top number 12, b to the 3rd, over, this is a 1. We'll have a to the 3rd, b to the 4th. Do I have anything else I can combine? B's, what do I need to do with their exponents? Yes, I'm going to subtract them I'll have 1b on the bottom, so I'll have a to the third, b to the first power, and just leave it b. You don't have to show every single step. I would like to see a little bit of work here, because that lets me know that you didn't just write down the answer, write down the answer, photo math everything. But as far as like what work you show, it doesn't matter so much, because you may do it a different way than somebody else. If you'd like to, yeah, that's fine. Just make sure you have it with you so I can check it tomorrow. And some problems don't really need work. For example, let's skip over to 23. What is 2x to the 1/3 to the 0 power? 1. So this is just x to the 14th over 1. So this is just x to the 14th, or arrow to the 14th, apparently. X to the 14th. So if you don't show work on a problem like that, that's fine. I just want to see some work somewhere, because I don't want to. I don't want you photo math in it. I know it's really easy to photo math the whole thing, but I want you to think about it and try. Photo math's pretty good on these. I didn't email them about photo math. I didn't think of it, but yeah. Oh, we got to do 18 here. We got to do 18. We might do some of these others, but we got to do 18, because I think you guys try 18. You guys try 18, and we'll see what you do. I think you're going to do it. I think at least some of you are going to do it wrong. There is a miss. It's not that difficult. I think that there's probably just going to be a misconception that shows up here. So try number 18. I want to see what you guys do. You might not mess it up. Actually, no, you're wrong. You have a mistake. You have a mistake. You're almost right. Yeah. Several of you get it. 2 to the 3rd power is not right.
Oh, I see what it is.
2 to the 3rd power is? No. 8. 2 times 2 times 2 is 8. It's as even as it. Yeah, right. Oh, you guys are too smart. Too smart. You're going to get it, I think.
That's wrong. That's wrong.
Oh, it's a coefficient, so your rate is 2 to the 3rd power. All right. I don't even know if I see anybody doing what I sometimes see students do. You guys are too smart. Okay. Here is what I see sometimes. And there may be another problem where you might be even more likely to do it. I don't see one right here. No. All right. Here's what I see some people do sometimes that is wrong. I see them take a coefficient and move it to the bottom. If I have something like -3 over x, -3 is not a negative exponent, right? Only negative exponents get thrown to the basement. Coefficients, whole numbers, we don't move those. So, like, this would already be, you couldn't do anything with that. That would already be simplified. I guess 17 is the same way. Like, sometimes I'll see students take 48 and move it to the bottom. That is wrong. We just leave it where it's at. We reduce it. It's only negative exponents that have to go to the bottom. So for this one, we're just going to square everything. Negative 4 squared is 16. You got x to the 4th, y to the 6th on top. 2 to the 3rd is 8. Where my 8 different? X to the 3rd, y to the 6th. Y's cancel. 16 over 8 is 2 over 1. I'm going to subtract my x's. I just have a single x. It's going to go on the top. There's nothing left in the bottom except for a 1, so I don't really have to write that 1. I would just say 2x. There. Oh. What's it? It's crazy. Okay. Okay. What's number 25? It's not.
Zero.
It is negative 1 because of this pesky negative that. So all the stuff in the parentheses is 1, but the negative's not inside the parentheses. Yeah. Let's look. 28. 28 is scary, but it's not as bad. Like I want to look at 22. What do I do with 22?
You murdered the children. That way it's just in there.
Your comments are disturbing me now. Y'all have to go that far. Yeah. For a short time until they start behaving. Okay. All right. First of all, do I have any negative exponents in number 22? No. What do I have to do with exponents there? I subtract them. This negative is like a coefficient. It's like having a negative 1 there. So I'm going to do 5n minus 2n. What does that give me? 3n. So I'll get, it's going to go on top because there's more x's on top. 5n is bigger than 2n. So I've got x to the 3n. And I'll keep that negative 1 there. So I'll just write it as negative x to the 3n. Let's see. Yeah, probably 28. Let's do 28. 28's the... Yeah, they're kind of similar. 28's a little scarier. Okay, you have a couple options here. You can either work inside of those parentheses first, or you could just like raise everything to the power first. I think I'd raise everything to the power first. So I'm going to raise every single thing over here to the negative 2 power. Crazy arrows are going to start popping up because this thing is... I'm going to just draw lines this time. I'm going to try arrows. So that is 4 to the negative 2, x to the negative 4, y to the positive 2, 3 to the negative 2, x to the positive 2, y to the negative 2. And over here, I'm going to have 2 to the 3rd power, x to the negative 3rd power, y to the 6th, over 9 to the 3rd, x to the negative 6th, y to the 6th. So 3 is going to be, the coefficients just get raised to that power. Because the coefficients, it's like they have a 1 for their exponents there. So the coefficients, they're going to get raised to that power. So we got 4 to the negative 2. Because we're doing like, the exponent here is 1 and we're multiplying it by negative 2. there. Then we multiply our exponents. So for that x squared, it's going to be, we're going to do 2 times negative 2, which will give us negative 4. And like the x that's in the bottom there, I had a negative 1 for that exponent, but when I multiply it by negative 2, negative 1 times negative 2 gives me a positive 2 there. Now, negative exponents just make things confusing here. There's other ways you can think about doing this, but I like to get rid of all of my negative exponents at this point before I start trying to combine. Because, like, for example, I think I heard somebody say, well, they might have been talking about these over here. Y's canceling out. These y's do cancel out. Do these? They're not going to, because you're going to be doing 2 minus negative 2, which is positive 4. So, but to avoid having to do that, here's what I usually do. This needs to go to the bottom. I'm not going to do that anymore. I'm not going to circle this stuff. All right. So that 4 squared goes to the bottom because it has a negative exponent. This x to the 4th goes to the bottom. You can write an x without it doing crazy stuff. X to the 4th goes to the bottom. This y squared stays on top because its exponent is positive. 3 to the negative 2 is going to go up here because it has a negative exponent. X squared stays on the bottom because it has a positive exponent. And then y to the negative 2, that's going to go to the top. Yeah. There. The y to the negative 2 is going to move to the top. But when it does, the sign will change on the exponent. It will become positive. So all of these here, I want to circle them, but it does that. All of these things with our negative exponents, they're going to switch to the other side of the fraction bar. So if maybe I should highlight, maybe that'll work. So like this, 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 and this, they all have to switch. So that's where we got like that 3 squared and this y squared and the 4 squared and the x to the 4th. All of those switched sides and became positive on their exponents. The x squared here just stayed because it had a positive exponent, so it just stays where it's at. The y squared here also stayed, right? So we also need to do the same thing with our second parentheses. 2 to the 3rd. Crazy arrows are popping up when I'm writing anything now. So I don't know what to do with this thing. 2 to the 3rd stays where it's at. X to the 3rd goes to the bottom. Y to the 6th on top there stays where it's at. 9 to the 3rd stays on the bottom. X to the negative 6 is going to go to the top and become positive, and then y to the 6 stays there on the bottom. Okay, so 3 squared is 9. That is a 4 right there. It's just a 4 squared. It's going to be 16. Oh, I'm sorry. On the top, yes, you will have y to the 4th. Yeah, we'll add those exponents right there, and we'll have x to the 6th on the bottom. Oh my word, it just keeps getting worse. I need to. Yeah, you add. It's not the problem. It's the whole worksheet. It's because it's in this compatibility mode or whatever, where it's an old worksheet. It's just crazy. We're almost done with what we're going to do together. So, yeah, we just add those exponents together to combine those there. Then in the second one, 2 to the 3rd is 8. The y to the 6th and the y to the 6th is going to cancel. 9 to the third, oh gracious, that's going to be 81 times 9, which is going to be 700 what? 729. And we'll have x to the third on top. Okay. So, now, when we have fractions, we just multiply across. So 9 times 8 is 72. X to the third, y to the fourth. Somebody use the calculator for 16 times 729 for me. I think 11664, and that's x to the sixth. So we can reduce that, I'm sure. If you're 1 over 162. All right, so we're going to have 1 over 162. X's, I'm going to put those together. Where are they going to end up? X to the third on the bottom. The y to the fourth stays on the top. Whew, that was a pretty bad one, wasn't it? And there's a circle. Now, this is like... This is like one of the most difficult ones you're going to see, right? You won't see most of the problems looking like this. You might just see a problem or two looking like this, right? Most of them will be a little bit more simple. You can put those together and make it x to the n minus 1, y to the 2n minus 3. All right, I'm not going to do the rest of those problems. You guys have 18 questions that are for your homework. They're going to start off pretty basic, and then they'll get to some that are a little more complicated. 16 is like about like the one we just did. Some of the others. Oh, we haven't done one like this. What's going to happen if you got to do a power to a power to a power? No. You can multiply these two together first. So you could make that 2x to the fourth y squared to the negative 6. And then you can raise everything to that negative 6 power. There. Okay. So your homework tonight is to finish these. You got about 10 minutes, so work on them now. You should be able to get maybe about half of them done before you go. And then tomorrow, we're going to review some, and we will have a quiz on our exponent rules. You don't have to finish the practice, just the ones that say homework. So 1 through 18, that's at the end of this worksheet.